Hello dear students, greetings to you all. This is Grishma, your faculty in chemistry. So welcome to my video session today. So in today's class, we are going to discuss few of the topics related to our subjects called chemistry. So let us have a small introduction regarding a topic called atom. Then continuation to that, how this atom related topics they are going to vary in groups and periods, talking about the periodic table. So you already know what is an atom. So atom is the smallest particle. The group of all atoms together makes the same type of atoms make an element. So there are different elements present in the periodic table. Among all the elements present in the periodic table which are being arranged in the groups and periods, there are some trends that are going to vary in the periodic table, like atomic radius, ionization enthalpy, electron gain enthalpy, electronegativity and electron affinity, nothing but electropositivity, which is also called as metallic nature, and how these trends are going to vary in the periodic table, that we are going to discuss in today's session. So before that, let me give you the small introduction with a basics to this topic, that you have to know what is an atom and what things are present in the atom. That is a basic thing. And apart from that, you should also know that what is screening effect, which is very important, will be continuously repeated. This word will be repeated in your trends when we are discussing. That is a different variations we see in the periodic table. So let me start this session. Yeah. Talking about an atom, so it is the smallest particle, as I already told. This atom consists of 3 subatomic particles. Those 3 subatomic particles are called protons, neutrons and electrons. So these protons, neutrons, electrons, all these 3 subatomic particles together make an atom. So these subatomic particles, they are represented with some symbol and they do have some charge. So protons are considered as a positive charge. So they are being represented as P plus. And the neutrons, they don't have any charge, thus just they are represented as N because they are neutral. And electrons have been represented with a negative charge, so they are represented as E minus. So in this way, these 3 subatomic particles, they are present within an atom. So if you talk about the atom structurally, where these things are located within an atom, so atom consists of nucleus in the center. So in this nucleus, there are protons as well as neutrons. So protons are positively charged. So I have represented some with a positive and some are with no charge. So here no charge indicates that they are the neutrons, right? So in the center of an atom there is a nucleus. So this nucleus consists of protons as well as neutrons. This makes a nucleus. Then what about electrons? Where are they located? So these electrons, they are located around this nucleus in a particular shell. So these are called shells, or they are also called as energy levels. So these energy levels are being represented by the numberings, that is n is equals to 1, n is equals to 2, n is equals to 3 and n equals to 4, and they are also being named as K, L, M and N. So these are the shells or the energy levels. In these energy levels or shells, these electrons are being located, which are revolving around this nucleus in the similar manner to our solar system, where all the planetary systems, they are going to rotate, revolve around the sun in the similar manner. There is nucleus in the center and the energy levels are around this nucleus. In these energy levels, the electrons are located, which are revolving around this nucleus. So this is a small little points related to atom. So talking about a very important key concept called as screening effect. So what is screening effect? You must know here. So this screening effect also can be called as Z effect. Screening effect or Z effect means the same. So what is the screening effect? So what is screening effect here is, if you consider the different shells, we have, this is the last shell. So this last shell can also be called as outermost shell, or last shell can also be called as valence shell. Okay. So now what is the screening effect with respect to this topic? The electrons which are present in this outermost shell, if the nucleus want to remove these electrons present in the valence shell. So what will happen if this if this nucleus want to attract these electrons towards itself, the innermost shell to the outermost shell. That means this is the outermost shell. Its innermost shell will be this one. So this innermost shell, it is going to protect the outermost shell from losing or attracting this electron towards the nucleus. So that means what? The innermost shell, it acts as a shield. So here you have to notice that this innermost shell is going to act as a shield. That means giving protection to the outermost shell from not losing it, not losing the electron. If the innermost shell is having only s and p orbitals, then only s and p are going to act as a shielding effect. In case if apart from s and p, if there are some d and f orbitals, if d and f orbitals are there in the innermost shell, they don't provide any shielding here. So that time it acts as a poor shielding effect. So due to poor shielding effect, some of the variations takes place in the periodic table. That things we will be discussing. So here you have to know what is screening effect means. The outermost shell is being protected by the innermost shell. For what purpose? For not losing the electrons. That means, so the electrons present in this outermost shell has to be lost, but the innermost shell is going to protect for the outermost shell. That is called as a screening effect or Z effect. Okay, I hope you are understanding. Yeah, please keep watching my videos. Next, let us discuss what are the trends we are going to see in the periodic table. So we have the different trends in the periodic table like atomic radius, ionization enthalpy, that is atomic radius. First let us discuss atomic radius. We have the different variations in the periodic table. So what is atomic radius? So if you consider an atom, here there is a nucleus in the center, around the nucleus there are shells as I told already, and this will be the outermost shell. So talking about atomic radius, the distance from center of the nucleus to the outermost shell, that means this distance. So this is the outermost shell. As I already told, outermost shell is also called as a valence shell or the last shell. So the distance from nucleus to the outermost shell or the distance from nucleus to the last shell. So this distance is known as atomic radius. Then what happens to the atomic radius? In groups and periods. So in groups, atomic radius is going to increase. So why it is going to increase in the groups? Atomic radius is going to increase. Why in the group? In the sense, as we move from top to bottom in a periodic table, these atomic radius is going to increase. Why? Because every time the electron is added for the new shell. So as we observe, if the first time electron is added to the first shell, next time it is been added to second shell, third shell. That means as the number of shells are going to increase, definitely the atomic radius is going to increase. So that's why when we are coming from top to bottom in a group, atomic radius is increases because every time we are adding the electron to a new subshell. So that is the reason it is going to increase. So talking about periods, this atomic radius is going to decrease in periods. So periods, we are moving from left side to right side of the periodic table. So within the periodic table, the periods are moving from left to right. So as we are moving left to right, these atomic radius is going to decrease. Why? Because we are moving from left to right. Every time the electron is not added for the new subshell. Sometimes it is being added to the same subshell. So that's why the atomic radius is not much increases. So as a result of that, in a periods atomic radius is going to decrease, but in groups it is going to increase. Yes, this is about atomic radius. Then talking about ionization enthalpy. So ionization enthalpy can also be called as ionization energy, which means the same. So what is ionization energy or ionization enthalpy? So now, what is this concept? I will be explaining here within this atom structure. So I want to remove an electron which is present in the outermost shell. So if I want to remove an electron which is present in the outermost shell, I do require some amount of energy. So that is called as ionization enthalpy. That means the amount of energy required to remove electron present in the outermost shell of neutral gaseous atom. So this is a keyword here. The atom should be a neutral atom. So from the neutral atom, I want to remove an electron which is present in the outermost shell. Then I do require some amount of energy. So that amount of energy which I require, that is called as ionization enthalpy. For example, take an example, there is some metal M, okay, from this metal. So this metal is a neutral atom. Neutral atom means what? There is no loss of electrons or gain of electrons. It is neutral in condition. Okay, so for this neutral metal atom, now I am applying some amount of energy. That energy I am calling it as ionization energy. So by applying this ionization energy to this metal, what I am doing? I am going to remove one electron from metal. So you already know that removing of one electron from the metal will get positive charge. So gaining of one electron will make the metal to get one negative charge. So since I am removing one electron from metal, by applying the energy called ionization enthalpy, so metal will become M plus. So M plus indicates here there is one loss of electron. So this is called as ionization enthalpy. That means the amount of energy required to remove an electron from the neutral gaseous atom of outermost shell electron. That is called as ionization enthalpy. So what happens to this ionization enthalpy in a groups and period? So in groups, this ionization enthalpy is going to decrease, and in periods it is going to increase. So why ionization enthalpy in a group is going to decrease? Because in group, as we come from top to bottom, this atomic size or atomic radius is going to increase. So due to increase in the atomic size and screening effect, this ionization enthalpy in groups, it is going to decrease. And why this ionization enthalpy is increases in the periods? Because in periods, atomic radius is going to decrease. So due to decrease in the atomic radius and increase in the nuclear charge. So as a result of that, in periods, ionization enthalpy is going to increase. So this is the one more trend that is going to see in the periodic table. So along with this ionization enthalpy, let us see one more concept, that is electronegativity. Electronegativity. So what do you mean by electronegativity? So electronegativity is nothing but the tendency of an atom to attract the shared electrons towards itself. So an atom or an element who has maximum capacity of attracting the electrons towards itself. So that is called as electronegativity. So if you talk about the elements present in the periodic table, so the most electronegative atom or element in the periodic table is fluorine. So fluorine is the most electronegative element or atom among the entire periodic table, because it has the maximum capacity of attracting the shared pair of electrons towards itself. So that concept is called as electronegativity. So talking about in groups and periods, what happens to this electronegativity? So electronegativity in groups, it is going to decrease, and in periods it is increases. So why electronegativity decreases in a groups? Because as we move from top to bottom in a group, this atomic radius is going to increase, and also due to screening effect and increase in the atomic size, in groups electronegativity decreases, and in periods electronegativity is going to increase. Why? Because as we move from left to right in a period, atomic radius is going to decrease, and due to which the nuclear charge will be increased. As a result of that, electronegativity increases in the periods. So I hope you are understanding. This is about electronegativity. Then talking about finally electropositivity. Electropositivity, or it is also called as metallic nature. So what do you mean by electropositivity? It is exactly opposite to the electronegativity. So in electronegativity, what did I tell is that it is a tendency of an atom to attract the electrons towards itself. So here that means in electronegativity there is a gaining of electrons. Attracting means there is a gaining of electrons. But talking about electropositivity, it is a chance of losing the electrons. That means the element or atom which has a maximum capacity of losing electrons. So that is termed as electropositivity. So electropositivity in groups and periods, what happens? So in groups, electropositivity increases, and in periods, electropositivity is going to decreases. So why it is increases in the groups, this electropositivity means because of increase in the atomic size, and here decrease in the atomic size. So I hope you all understood about today's class. Thank you everyone. Signing off. This is Grishma.